Let's start sharing screen. Okay. Can you see my screen?
Yes.
Okay, excellent. Okay. Welcome to the African Plants Georeferencing Trainers Workshop. This is module 4. And in this session, we're going to go through some of the functions that Google Maps, Google Earth, and GeoPick offer and that we are going to use to aid georeferencing. Just as a very, very quick introduction, when we talk about georeferencing in the bigger picture, we're talking about a much larger process than the soil calculation. And this includes from the capture and management of the data to the interpretation, standardization, georeferencing, and then quality control, and finally data sharing. So we basically in this course focus on these 3 points of the process, these 3 stages, which are interpretation, standardization, and georeferencing of location data. So, sorry. These steps may include different kinds of actions and resources that we can use. And so those actions go from search of the location, visualizing them, for example, on maps, delimiting the different features that those locations refer to. We may need to convert coordinates, and finally calculate the georeference, which means calculate also the uncertainty that is associated to a given location. And well, we can also validate georeferences that we have or data that we have. So the tools that we're going to see today, in particular Google Maps and Google Earth, mostly help us to find locations, to visualize it, and to be able to delimit them. And then the third tool that we're going to explore, GeoPick, what it does is, aside from helping us to search, visualize, and delimit, it helps us in the actual calculation of the georeference. That means getting the final coordinates and uncertainty, and in particular for types of localities that are features only. So this is what we're going to be seeing today. So the different functions that we will explore, depending on the tool, we will see that, are different kinds of views that we can have, like maps views, street views, satellite views, etc. How to search on the different tools. We're going to explore measurement functions, like how to measure distances and areas and elevation on Google Maps and Google Earth. We're going to see how to draw and save points and polygons and polylines. Also, how to deal with historical images. And finally, for GeoPick in particular, how to get georeferences from this tool. So this is more or less the schema that we will follow. So this session is going to be a demo type session, which means I'm going to open the different programs, applications, and show you how to do different things. So that said, let's start, and we're going to begin with Google Maps. So let me go out from here and into Google Maps. Okay, let's refresh this to 0. Maps. All right. Can you see my map fine?
Yep.
Okay. Excellent. Okay, so this is Google Maps. And this is how I see it, because I have it set to show me a globe, but you may see it just flat. I'm going to show you how to change that later on. So let's look at, this might be very obvious to most of you, but just in case, I'm going to go through it. So we can move the map by clicking and dragging around, like, and we can zoom in and zoom out in generally two different ways. I can double click on the screen to zoom in and double click with my right click to zoom out. In my computer, the mouse pad allows me to, with 2 fingers, to zoom in and zoom out if I want. It depends on whether you use a separate mouse or a mouse pad. And we also have down here at the right the zoom slider, which allows us to zoom in or zoom out. This is very, very basic. Now let's move here to Africa. Okay, and let's zoom out a little bit. Oh, sorry for that. Okay, so here we're seeing the default view that Google Maps opens when we open the application. But one thing that I didn't say is that Google Maps works online, and so you have to be connected to the internet to be able to use it. So that's somewhat of a disadvantage in general. We're going to see that the other the Google Earth has the advantage of, for some things, being able to work without connection, but Google Maps requires connection. So this is, as I was saying, this is the default view for Google Maps. But down here at the very bottom left corner, we can see other views that we can explore. So the one that appears first, for me at least, is the satellite view. And so if we click on satellite, we have the satellite view. But we can also explore other layers, for instance, terrain. And terrain, you may think, well, this looks pretty similar to the first view that we were looking at, but it has a very interesting feature, which is down here. You can see in the middle at the bottom that I have enabled the topography and elevation. That's what terrain is doing. And so I'm going to go to a mountainy area so that you can see when we have elevation, the terrain view enabled. Well, I'm not seeing what I want to show you. Wait a second. See if we can get some let's go a little down. Okay, so I'm going to go again to the terrain, and in here, if you zoom enough, you get zoom in, you start seeing the elevation lines, the ISO lines of elevation. So there. So you can determine the elevation by following this topographic lines. So that we can see in the terrain view in Google Maps. So again, you have to zoom in quite a bit to be able to see the lines, and the more you zoom in, you may get more detail. If we start zooming out, we start losing details, as you can see. So if you want to make sure you're looking at the right elevation, sorry, connection is there. You should be zooming in as much as you can to be sure. Okay, so going back to here, we have other layers that we could use: traffic, transit, biking, but these are not generally not layers that we will use for georeferencing. If you go to more, you can find all the different views listed here. And in there, you can see that I have checked globe view. And this is what allows me to see the map as a globe. If I disable this, it's going to make it all flat. You can enable and disable it there. Remember, this is here, layers, more, and you will find it there. Okay. So I'm going to show you just for, you see, if I zoom out, and now I see it as flat, right? And if I enable the globe view, I start seeing it as a globe. It's just that. Okay, so I'm going to go back to satellite view. And in satellite view, if having the globe view enabled, down here at the very right, there is an option to see 3D. And so let me go to a very big mountain so that I can show you the 3D better. Okay. So this is where we actually live, down here. Right there is where we live, and this is the Cordillera de los Andes. And I'm going to show you the 3D view. So I just put 3D, that's 2D, 3D, and we can zoom in, and you will see that it is actually 3D. So this function may be useful if you're, for example, if you have a location that says west slope of a given mountain, and then you say, well, where does the west slope ends? Sometimes when the map is flat, it's very difficult to tell. Maybe when you're looking at the elevation lines, that can help, but otherwise seeing it 3D, sometimes it's much it's easier and also much more fun, I think, than seeing things in a more realistic way. So that is the 2D and 3D option there. Now, I didn't mention it, but here there is a compass. We will see that we will need it in a moment, but the red arrow points to the north. And if the map gets disoriented, we can always go back to the compass to reorient the north upwards. And the last view that I want to show you is the street view. And I'm going to go back to Africa here. And let's go, for example, to Durban. I don't want to click on the map because I'm going to talk about that a little later, but if you click on the map, things will happen. So I'm going to go to Durban here, city in South Africa, and I'm going to show you the street view. The street view can be very useful to find some places. So if we click street view, what happens is Google draws on the map all the streets and routes for which they have pictures. I mean, real life pictures with the little Google car that has gone over streets throughout the world, taking pictures of every block and stuff. So it's actually very interesting to see. The beauty of this is that when we are in street view, we can pick this little yellow doll here down at the very right, and we can drag him to any of the streets that we want to look at. I'm doing this in a very small zoom, so ideally I should be zooming in as much as I can to be able to select the street that I want to see. But suppose I want to see that one. What it's going to do is take me to that street immediately. And so by clicking and dragging, I can go around and see all the things that are in that street that I chose, which is a corner in this case, but I could have chosen the middle of a street. And also I can move around. So for example, if you see these X's and arrows here that appear on the screen, I can move. If I click, I'm moving on this street on that direction against the traffic. And if I want, I can keep going and I can turn in the next street down and so on. So I can see everything around. So sometimes for finding some locations, this is very useful, especially if they are contemporary location descriptions, because we can actually see the things on the images. Now, if you look carefully down here at the very right, you have the image date, and also here at the very top left, it says May 2023. So these images are from last May. However, for some places, not for all, but for some places, we can see more dates. This means that we have more than one image for for this place. So for this corner in particular, we have images from May 2023 for 17, 15, 13, 10, up to 2009. So we could check how this changed over time from this image to this image here. So there we have, let's see if that changed. I'm going to go to September 2009. This was some sports shop. But if I go back to, oops, sorry, to 2009, let me go back with the little guy there. So right now, or in May, it was a sports shop, but in 2009 was something completely different. So you can see that with these images, we can track some locations over time quite easily. Again, this is not going to work for historical locations because we don't have pictures from back then in here, but it's still useful for some locations. Okay, I'm going to go out from this view, and I'm going to go back to my satellite view there, and okay, we're in the middle of the city and with a satellite view. So now you see that this map, because we have been moving on the streets, we have changed the directions, and so the map is heads up. For instance, if you look at the compass here, now the north is to the right, and so we can reorient that by just clicking on the compass, and it will put the north up again. Okay. So that's for all the layers and the things that we can do with them. Now we're going to see how to look for different places in Google Maps. So the most basic way to look for places is here in the search bar. So I'm going to look for instance, Kisii in Kenya, and we're going to go to Kisii, and we find Kisii there. Okay, that's great. So on the left side, on the left panel, Google provides us with some information about that place, if it has it. It doesn't have information for every place in the world, but for many it does. And photos and stuff that people have shared with Google. Now, what is interesting here to see is that Google is providing a polygon. So you can see these red little dots here around Kisii. That's a polygon that Google provides for this location. The disadvantage of these polygons in Google is that we cannot download them. And so we can visualize them on Google Maps, but we basically cannot use them. We cannot put it anywhere else nor do anything with them. But still, it is a very powerful tool to help us delimit a given place. Now, careful with those polygons, because we don't know who made those polygons, and we might differ in what we're including within those polygons. For example, if we were to draw the polygon, would we draw it the same way? Well, maybe not, maybe yes, maybe in some parts we would do it differently. Like, for example, in here, up here, why is this polygon going up here and not finishing there, or taking all this part up north? Well, we don't know that because we don't know who made this polygon and which were the criteria that they used. But still, it helps us to more or less figure where this location is. And we can use some modification of it if we're, for example, drawing our own polygon for Kisi, either in Google Earth or in GeoPick. So that's about polygons. Again, not every location has a polygon on Google Maps, but sometimes we are lucky. Then another way of searching for places, let me go. I can see my other. So that was the search here in the search bar. Another way is clicking on the map. So as we zoom out and zoom in, names appear on Google Maps. And so, for example, here we can go to the names that we find and we can click on them and it will take us to those places. So if I wanted to see Kisi, again, I would click on Kisi and it will take me to Kisi. So we can click on the names and it will take us there. If I go to Marani, it will take me to Marani. If I go to, let's put another one, Bonshushu. I hope I'm pronouncing this correct. Sorry if I'm not. And you see here that for this place, it doesn't have much information, but it is telling us at least in which country it is, which is some information. And so, well, depending on the location that we're looking at, we can find more or less information. As you have seen, the names that appear depend on the zoom that I'm using. So the closer I get to the terrain, the more detail that I will have. So take that into account, because sometimes we can't find some names, but when we zoom in, we do. And also, specifically for lakes, what happens is that sometimes at some zoom, the name appears, like in here. If I was up, well, now it's appearing, but a moment ago it wasn't there. But as I start to zoom in, it will appear. And sometimes you have to zoom in quite a bit for it to appear. And if I'm with this zoom and looking at this side of the lake, I'm not going to see the name. So I have to go to some other place of the water body to actually see the name. This is sometimes bothersome because one doesn't know a priori which is the zoom to use to see the names, but know that that happens, that sometimes names are difficult to find because of that, of the zoom level. And one other thing that I wanted to show you was to look for locations. One could just click on any place on the map, whether it has a name or not. And so, for example, I'm going to click here. Let me go to there, doing it at zoom. And if I just click on the map, see what happens. It appears here where that point is. In this case, it's in Silambo, Tanzania. But it gives me the actual coordinates of the point where I'm standing, of the point that I chose. Careful, because this description, Silambo, Tanzania, is not the description of the place. It's telling us a general reference of where that point is, because it doesn't have much more detail, Google Maps, for that. But it does give us the coordinates, and so we can get those coordinates. And if I click on those coordinates, it's going to put a point there. There is the point of my coordinates, and it's going to give me the coordinates here in two different formats: degrees, minutes, seconds, and decimal degrees. Careful, do not take this as the description of that point, because this is not the description of this point. This is in general terms where this point is, but it's not the specific description. Also, these codes, we do not recommend using these codes, or codes that Google provide, but those are not a good description of the location. Remember that verbal descriptions should be as specific as possible so that we can determine the locations unequivocally. Well, we can put the points there. We can, for example, select another point there. And again, it will give me the coordinates. And what I can do with these coordinates is if I go to them, it opens here an option to save them. And so I can save that point, and it's going to save it to my own list of places on Google Maps. So if you have a Google account and you're logged in, check that I'm logged in up here with my email account, so you can save your places. So I'm going to save it to lugares, which is in Spanish places, and I'm going to save it there. Here it says it's saved it. And so if I go out from here and zoom out, get away, do something different, well, you see my point there saved. And so I can go here to the menu, general menu, to my saved places, and say, well, this was in this folder, places, and it was this one. And I can click on it and go back to it, which is not showing right now, but it's there. So let's give it an enter there. Oh, it's doing something weird. Let's give it just there. Okay, so I came back to my save place. What I did here, just for the record, is that it put all the coordinates there, combined the degrees, minutes, seconds, and the decimal degree, so we couldn't find it. So I just kept the decimals there from what I had saved. And so we can have a collection of points saved on our maps for our later use. Again, we cannot do anything else than that. I mean, we cannot export those points as far as I know, but we can use them within Google Maps. So that's about saving places. And now the last thing that I want to show you is how to measure distances and areas on Google Maps. So let's go to some other place. For example, well, let's go to some place that has a road or a crossroads. Any place with a crossroads that we can measure. Okay. So here, let's take a slightly shorter one. Just to, okay. Suppose that I want to measure the distance between this intersection, N1 and N16, and the intersection between N1 and this road, which in here I don't see its name. But between this point here, I hope you're seeing my mouse, and the intersection between N1 and N16. So what I will do to measure is right-click with the mouse and go down, and a menu opens, and I can go to measure distance. With measure distance, I can start here and make, sorry, because I was in the other side. I can start here with a click and start adding different points following the route. So I'm going to do it like this, and you will see why. So we can measure the distance between 2 points, and down here, Google Maps is going to tell us the total distance of that path. In this case, 3.78 kilometers. Also, we can have an idea of the distance between the different points that we have put. And we can edit this route. For example, in here, I'm going to zoom in. I did a terrible job following this route, and so I can click on each point and move it and correct it. So I'm going to correct this one here, and I can add another one in the middle. So I'm going to add that last one and move this one here, and I can move that one there, etc. So we can move and adjust the route that we're having. And then if I'm mistaken and add more points, I just click on those and by clicking on those, I can erase them. So, and I can come here again and adjust this there and so on. So we can measure distances on paths right here on Google Maps. Now, if we want to measure areas instead, so instead of doing a linear feature like in here, we're going to draw a polygon. And so I'm going to close that, open again, measure distance. And I'm going to, here we have a Jardin Botanique de Kisantu. We're going to measure the area of this botanic garden. So I'm going to start measuring. So I put there. I'm going to go around here, the river. I'm going to do it not very carefully so that for the sake of keeping time, but so that, oops, sorry, so that you see how it goes. So in the last one, I'm going to click in the first dot that I made just to close the polygon. And when I close the polygon, down here, instead of the of just the distance, which will be the perimeter, which we have here, total distance at the very bottom, that's the perimeter. We also have the total area of that polygon. So we can calculate areas here. And again, we can drag the points and add more points if we want. For adding points, careful, because each point that we add is always from the very last one. So to add points in the middle, you see what happens. I want to add a point here, adds it at the very end. So I have to move this one and reaccommodate. Well, this was the last one, reaccommodate the ones that were left in the middle. This one was erased. Okay. You see in there, I opened up the polygon. I don't have the area anymore. I only have a distance because it's actually a path. And if I close it there, I will have the area. Okay. Again, these polygons are very useful, but I cannot save them. And so I can only look at them here on Google Maps, but I cannot export them to anywhere else. So it's a useful tool for some things, that we will see that we have much more powerful tools in Google Earth and in GeoPick. I think that's all that I wanted to show you here in Google Maps. So is there any question about the things that we have seen so far? Any questions on the chat?
None so far.
Hello, Paula.
Hello.
Yeah, this is very interesting. So everything is fine so far with me. Thank you.
Thank you. I see a raised hand, Boucherie.
Yes. Hello, Paula.
Oh, Fabrice.
Hello?
Okay. Hello.
Yeah. Hello. I would like to ask you whether how you put those dots, because I'm not getting where. In fact, I'm not getting how you were putting those dots in that shape you are creating. Thank you.
Okay, I'll do it again. I'll show it again. So to be able to make those dots, I have to right click with the mouse. So I right click and this menu appears. And in that menu, down at the very bottom, there is measure distance. And so you have to click on measure distance, and then you can start clicking on the screen. Check if you can see that menu and let me know.
Yeah. It is working. Thank you.
Okay, excellent.
Hello, Paula.
Hello, John.
I would like to ask, I have seen how we can calculate the area, but I don't see about the perimeter. Is it automatically, it becomes automatically, or you need some manipulation? Good.
No, both the area and the perimeter are calculated automatically. So in here, for example, the shape that I have on screen is an open one. And so it only has the perimeter, that is the total distance that is measured down here. If I close this one, it becomes a polygon. And so it gives us the total area and also the total distance. And that total distance is the perimeter of this shape.
Okay, good. But I'm still having a small question.
Yes.
For example, in this garden, for example, we may have like a small plot, which is not a garden. And then how can we calculate the area of these excluding the small plot, which may not include, which may not have like the garden plantations? Are you getting my question?
Yeah, I think so. Let me see if I can explain how. Suppose that this or this space here was not included, but this is and this isn't. So what I'm going to do is a polygon. We have to kind of be more artists than scientists here. So what I would do, suppose that this is the garden, right? So this just this part, but not this little part. So we would have to draw a polygon here that excludes that. It's not easy to do, but I will probably, let's see what will be the best way to do this. Well, if this was all of it, I would do something like that and that and that and that and come back here. Oops. And you have to work in a much bigger zoom. That's one way, trying to avoid that and make a more complicated shape. That I'm going to exaggerate it here. Let me see if I can do that. So I'm going to do it like that. So in that way, what we will have is the area of all this part except that. This is not a very practical way to do it. So the more practical way to do it would be to get the whole area and then write down the area and then draw another polygon with the area that is not included and just subtract the values. The problem with Google Maps is that it doesn't allow us to save these polygons. So that's a pain because we cannot go back to the first polygon that we drew. What we can do that much easier in Google Earth because Google Earth we can save the polygons. But in here, these two would be the solutions. Either make a weird shape by hand, or make two shapes, a bigger one and a smaller one, and subtract them. Does that make sense?
Yes. Maybe we shall see it in on the Google Earth.
Yes, we will. We'll move to that after we're done with Google Maps.
We have a question from Nestor.
Okay.
He asks, is it easy to draw polygons? No, he says, it is easy to draw polygons for the park, but how do you draw for a town? For example, Durban.
That's quite a question. It's a very good one. We have to take criteria. So let's go for Durban. Durban was the example, right?
Yes.
Okay. So when I look for Durban, see what Google Maps gives us. This is a weird polygon. So it's saying, well, Durban is all this included here. Let me go to the straight to the default view so that maybe it's clearer. So it's this, but this part in the middle doesn't seem to be inside Durban. I'm not familiar with Durban, so this probably is called something else, or for some reason is not within the center, the city. It would be very weird, no? This. Now, if we go back to the satellite view and we see all the streets, it's very difficult to determine which are the actual limits. And so we need to take some criteria. So if we know of other places, like for example, Durban North here, and we know that Durban North is a separate thing from Durban, it's a different city, town, municipality, we can say, well, there is a limit up here. Similarly to the west and to the south, we can say, well, down here, whatever is in here around Isipingo and Prospecton, etc., is not in Durban. But we need to have that information from some other source. We have to look for Durban in Wikipedia or in gazetteers and try to find what the extent of the city actually is. It can be very, very challenging. And again, the polygons that we see here on Google Maps may not be accurate. And so we may need to redraw ourselves. For Durban, it's quite a difficult case. Let me go to a smaller town to show how we would draw a polygon, but we have to scale that to very difficult situations like big cities. In here, we have Pinetown, and so we could draw a polygon that goes all around here and say, well, I'm going to decide, because this is a decision, it's a criterion, I'm going to decide that the polygon goes here. Let me draw it. And I'm going to include this part, but not anymore. And so I'm going to do that, right? I'm going to say, well, this is, the limit is the river, and here the limit is this road, and here I have to decide whether if I go here and include that or not. Now, if I zoom in, you will see that where I put my polygon here, I determine that this is probably part of the town. So I have to go zoom in and decide whether I'm going to include that or not, and try to find in other sources what the limits of the town are, and so help with those sources to delimit the location. It's a very, very difficult exercise. It's I believe the most difficult part of georeferencing is this, determining the actual extent of a location, because it's, in some cases, it's pretty subjective. And so that's why it's so important to document our criteria and the sources that we have used. Again, we will see this again in Google Earth, but depending on when the image is taken, we will see different things. So again, we will see it in Google Earth better because it shows it better. But this image is from 2023, this image of this town. However, if we looked at this town 40 years ago, it probably was very different in shape, in size, in everything. So that varies a lot. And therefore, we have the time issue to consider as well. So criteria, sources, report all of that. In general terms, anyway, don't get frustrated and desperate, because whether you include one more block or one less block, when we use the point radius method, especially for big shapes, it's not going to make much of a difference. Why? Because whether I put this point here, let me move it, or there, the circle around it is going to be much bigger because of the shape of this location and the size of the location. So including one block more or one block less, in this case, is not going to make much difference, because the radial is already going to take care of it. The circle is going to be much bigger, and so whether we include that point there or here, the circle is going to be more or less the same. We do have to be very careful, however, when we set the extreme points, because the extremes, the further points are the ones that are going to determine how big the circle is when we're using the point radius, which are the how to better draw the circle to include them all so that the circle is minimal. And so those points are more critical than the ones in the middle. Again, it depends on the shape of the location, but in general terms, it's like that. The further the extreme points are more critical. I hope this answers. I know it's not a definite answer.
We have 3 more questions on Google Maps already.
Okay.
The next one is from Beston, and that is, if you could please repeat how it was that you were able to get and save the coordinates of a specific point on the map.
Yes. I may close all these things. Okay. Let's go to a spot that doesn't have so many things on the map. So around here. So suppose that I want to say exactly this point here where my mouse is. So I'm going to click on it. I click on it. And when I click on it, down here, it gives me the coordinates of that point. And so clicking on those coordinates, I click on those coordinates, and it opens it here. And you can see these are the coordinates that correspond to the point that I selected. And so there I can click save and choose which folder I wanted to save it to. I want to save it to this one. And so down here it says it's saved to that folder. And so when I want to go back to it, I have to go to the general menu here on the top left and go to save places. And in the corresponding folder, I will find the place that I just saved. Well, I have many here saved, but this is the last one that I saved. Check that when I click on it, what it does is put everything here, both formats for coordinates. So I'm going to leave just the ones that are decimal, and I click enter, and it's going to go to that same point that we saved. Does it answer the question?
I think it probably does, but there's another way that it can be done as well. If you right-click on a spot and get that same menu that has measure distance, right there at the top is the option for the coordinates too.
Here. Those allows us to click to copy them as well. I didn't mention that, but if we click on a spot and we do right click and we click on these coordinates, it doesn't go to them, but it copies them to the clipboard. So we could just copy and paste somewhere else if we wanted to. For instance, the coordinates there. Here is taking that point. So if we put a point here and we do right click and click here, it will automatically copy the coordinates.
Okay, we have another question with a very straightforward answer from Peter, and that is, at the same time, can you input the coordinates to form the polygons?
You can search here for coordinates. I don't think you can build the polygons because you have to use the measure tool for that. And so by searching with the polygons, you cannot do that on Google Maps. So I want to show you an example. Here I have a polygon that, wait a second. Oops.
I don't think that polygon will work in Google Maps anyway,
no,
because the latitude and longitudes are switched.
Well, it could work as a polygon anywhere else, but it does not recognize a polygon for a search at all. So you can only search by pairs of coordinates or by named places. But if you put a polygon here, a polygon structure, like this, where the polygon is It's telling you longitude and latitude for each of the points of the polygon, longitude, latitude, comma, longitude, latitude, comma, etc., for each point. Google Maps does not recognize this this format, so you cannot open polygons here. You can do it in Google Earth. We're going to see how to do that on Google Earth, how to open polygons there.
Okay, we have another question from Nestor, and again, this is going to highlight differences between Google Maps and Google Earth. The question is, does the calculation of distance with Google Maps take into account the relief?
The relief, you mean the terrain? The terrain?
It doesn't follow the terrain.
I don't think so.
No.
No. In Google Earth, we're going to see that there are elevation profiles, but I don't think Google Maps does that. I think it just measures the linear distance.
Yeah, that's right. And in Google Earth, you have the option to have the distance measured along the surface as opposed to a straight line distance. That's it for the questions in the chat.
Okay. Are there any hands up? Because at some point there was one hand up, but I'm not sure that that was answered or not. I think
Hello,
it was
Paula.
Pulshari. Hello.
Yes, that was me who raised the hand. So I wanted to comment on how to produce a polygon from a point, from a different point. So in QGIS extension, GIS extension maybe, or so there is a notion of point to path. So if you have many points, you can convert them into terrain. So it's a point to path, and then there is another option for converting line to polygon. So there's an extension available in QGIS. Yeah, that's my comment. Thank you.
Thank you. Yes, if we are using GIS, we can do a lot more than using Google Maps. That's for sure. In this course, we're not going to see GIS tools. If you're super interested in that part, we can talk on the side how to do some of these things in QGIS. But the idea is to show simple tools that everyone can use, because GIS requires much more training to use the tool itself. And so we're trying to use tools that are accessible and simple to use for everyone. But definitely you have many more options in QGIS or in any other GIS, actually.
Okay, Pulshari says that her question has been answered, and then the final question is actually leading us on to Google Earth, because the question is, what's the difference between Google Earth and Google Maps?
Well, there are many differences between the two in the things that we can do. And Google Maps is, think of it as a tool to be on the street and get somewhere. It goes more towards that kind of use, while Google Earth is more working with the location and allows us to save our information and to save polygons and to go back to them and measure different kinds of things, and allows us, we're going to see this, allows us to overlap different layers. It's like a GIS, but simpler. Let's say it doesn't allow all the things that GIS does, of course, but it's like a pseudo GIS. But Google Maps is not meant for that. Google Maps is meant for, I need to find this shop. Is it open? How do I go? How is the traffic? Oh, see that it's more, it's another kind of use. It's still useful to us because it allows us to get a lot of information. But its purpose was never georeferencing, I would say.
Okay, we've got a new question on Google Maps before you go to Google Earth, and that is, if we have geographic coordinates, how do you place them on a Google map?
If we have geographic coordinates, what we can do is paste them here on the search bar. So I'll show you here. I have a couple of geographic coordinates here, which I paste. I did copy paste. We can do it with the right click or with Control-C, Control-V, however you like to copy paste. So what I'm putting here is a pair of coordinates. So I'm putting a comma in between. There are a couple of formats that Google Maps recognizes. It does not recognize just any format for coordinates. Decimal coordinates it recognizes degrees, minutes, seconds, with minus signs or with hemisphere letters like east, west, north, south. Those formats it recognizes. So I'm going to put these coordinates here, and I'm going to do enter or click here search, and it's going to take me to those coordinates. And it's going to show me the dot. So once it shows me the dot, that point here is the point for the coordinates I enter, and so I can save that point. One thing that I didn't say is that you see this image here that looks like a church. Clearly, there is no church in the point where I just where I'm standing. However, it's given the image that is closer to that point, that it finds closer. So don't trust the image that you see here, but do trust the coordinates. The coordinates are okay. And so I can save that point if I want. I hope that answers that question.
I think we should do a time check here. We're at 20 minutes to the hour, and I think this took
Yes.
longer. Decide
Yeah.
whether you need to make your break or go into Google Map Earth right away.
How are you all feeling? Should we break now? We can do a 10-minute break now and then continue with all Google Earth.
We should have a 10-minute break.
Okay, I see a hand raised, Alexis.
Hello, Paula.
Hello.
I'd like to ask a question which is concerned to the cycle. When you are calculating the radial distance in the cycle, I don't know how we can point the center in the shapefile because of when you are looking at these punches, to have the different shapes. So how can calculate the area of the shapefile, which is have the form for the cycle shapes or cylinder shapes, because of it's somewhat complicated. So I'm not understanding very well how we can calculate radial distance and by referring to the center of the cycle. Thank you.
Sure. We're going to go back to that question. Alexis, it's a very good question. We're going to go back to that one when we see Google Earth, because then I can show you the circles and show you how to calculate the radials. So on Google Maps, I cannot show that because it's Google Maps that does not allow to draw circles. There are other tools that we can use on top of Google Maps, but it's better if we see it on Google Earth. So if you can wait with that question until we see the circles on Google Earth, I'll probably answer your question then.
Okay, thank you.
Mm-hmm. Are there any more questions in the chat? Okay, let me check the chat.
Nope, nothing left in the chat.
Okay.
No hands up.
Okay, what do you think about a break?
We had
No.
one vote for a break, so it sounded a little bit desperate.
Yes. Okay. Okay.
There's another break vote.
Okay. Okay, let's do that. I'll stop sharing now. Let's do that. Let's take a break. Let's take 10 minutes, and then we come back and start seeing Google Earth, which I think you're going to love the functions that we're going to show you. So let's break.
And if you don't, Paula's
no.
going to make you love it. I guarantee.
Okay. Okay, 10-minute break. See you soon.
See you. Thank you.
Okay, we are back and we will be starting. See how many people we have. There are a couple of people missing, but I think we should start because we only have an hour left and we have a lot to see. So welcome back. We're going to show you now how to use some functions from Google Earth. So let me share my screen. Okay. Can you see it there? Can someone confirm?
Yes.
Excellent. Thank you. Okay. So this is Google Earth. I'm going to be using the desktop version of Google Earth that works on my computer. There is also a web version that you can use, but I tend to prefer the desktop version for a couple of reasons. First, because I believe not all of the functions are available in the web one, but mostly because it allows me to work offline for many things. Google Earth does connect through the internet and loads images, but if you're working offline and in a particular region and you have all the things in the cache, you can work without a connection. So that's a huge advantage for us. So Google Earth looks like this on the screen, and we're going to go through the very basic functions first. Up here on the right corner, upper right corner, there is a compass where you have the north that you can click and turn to orient. If you click on the end, it automatically orients it towards the north upwards. You have a series of arrows that you can move to see the things more straight down or more inclined. Also to the sides, this moves the compass. You can move up or down and to the sides, that is in latitude and in longitude. And you have the zoom here. So by clicking on the minus or on the plus, you can zoom in and out. And you can also do that by double clicking on the screen. So if you double click here, let me go to where they're in South America. Let me go to Africa. Let's orient this north. And so if you double click, it's going to zoom. Just with one double click, it zooms that much. I double click again, and it keeps going in with a greater zoom. So that's the general controls. As you move through the map, check the little hand that is on the map. As I move around, down here is showing us the latitude and longitude and the elevation. So check how when I move my little hand, when I go over the map, that longitude and latitude changes. The elevation, however, we see that it doesn't change. So I'm going to show you how to enable that. Let's go to a more mountainy area so that you can see the differences. I'm going to zoom in a little bit. Okay, so far we're changing latitude and longitude. Now, In the left panels here, I'm going to explain what these panels are. The first panel is a search panel. Then there is a panel for the places, which are the places that I can save, and the temporary places that we use while we're using Google Earth. We're going to see this quite a bit later. And we have a panel here for layers. Among these layers, there is one that is called terrain. So if I click terrain, it gives us a terrain view. And now when I go through the map, down here, you can see the elevation changes. So check how that increases or decreases as I move around at different places of the map. So we can get elevation of different points on this map from Google Earth. If this terrain is not enabled, we lose that information, but we can always turn it on and off from this left panel. So that's for the terrain layer. We're going to see other layers later on. But one thing that I wanted to show you first is how to change some settings in Google Earth, because you can see here that the latitude and longitude for me are given in decimal degrees and the elevations in meters. But depending on your settings, this can be in other format. So to change that, we go up here to Tools, Options. And here we can change a series of things. I'm going to just mention two, which are latitude and longitude and units of measurement. So for latitude and longitude, I can choose different formats. And for example, if I choose degrees, minutes, seconds, check how the coordinates down there change. I choose degrees, minutes, seconds, I click apply, and now down here, I have the coordinates in degrees, minutes, and seconds. If I want to go back to decimal degrees, I click decimal degrees, apply, and then I have it in decimal degrees. Same thing happens for units of measurement. Here I have it set to system default because my system is already in the metric system, but I can choose it manually. I can say, give me the measurements in meters and kilometers, or give me the measurements in feet and miles. If I put feet and miles, check how the elevation changes to feet down here. So I'm going to set it back to default, which is in the metric system for me. So now my elevation is showing in meters. There are other things that you can change from here, from these options, more general options. I'm not going to touch them now, but you can explore these menus. Okay, but those are important because if you are set to degrees, minutes, seconds, it's probably more useful that you change it directly to decimal degrees for the purposes of georeferencing. Okay, now how do we look for places and use these different layers here? To search for places, we have the search box here. And so we can do exactly the same as we did before in Google Maps. We can look for Kisii in Kenya. And so here we have different options as well. Let's go to the county, just for the sake of showing. We do a search, and it finds the Kisii County there. And it gives us basically the point that corresponds to what it understands is the center of the Kisii County. If we were to look for the Kisii town or city, which is up here, I would put Kisii and Kisii, Kenya. This is going to give us the town. I do the search, and here we have the town. As you can see, Google Earth is not showing us here the polygons that Google Maps might have. So again, it's always useful to work in combination with the different tools. Now, I want to show you some layers that we can use. The layers are here in the bottom left. You can make it bigger or move them around a little bit. And so some of the layers that we will be using that are most useful are, for one, borders and labels. So these show us, let me zoom out, borders for some administrative divisions, as you can see. And it shows us the labels, which are the names of places. If I unclick that, it disappears. Here I have Kisi, but because it was on my search. So if I take out the search, sorry. Okay. So that was Kisi. So if I don't have the borders and labels clicked, it's not going to show borders and labels, but I can click it and it will show the names of places and borders. In here, you can choose whether you want just the borders or just the labels. So this is one useful layer. There is also a layer called places. And for this one, if we zoom in, let me see if in Kisi we have places to show. Here you can see that some places appear. And if I take it out, those places disappear. The kind of places that appear depend on the information that Google has about the place. So it can vary quite a bit. It's not going to show every single place in that city, but the places that it has loaded. There is also another layer that is called photos that sometimes is useful. In here, it doesn't seem we have many photos of Kisi there. There they start to appear. I'm not sure if you can see them, but they're little circles that if we click on them, the photos appear for different places. These are photos that people have uploaded to Google. So again, it depends on what the community has shared, what the pictures are. Now, we have to be careful because those pictures are put on the map by the people, and sometimes they do it with different zooms, and so they are not really where they should be. But sometimes it's useful to take a look at them. A more useful layer is the layer of roads. And so when we click roads, all the roads appear. So let's zoom in so that you can see. So here you have in white and yellow all the roads. If I disable it, you see that it's not marked anymore. So that can be also a very useful tool. And then there are other layers here, 3D buildings, weather, gallery, etc. that we're not going to go into the details of those now because those are not the most used ones for our purposes anyway. So that about layers and looking for places. Now, one important feature, very useful feature from Google Earth is the historical images. And I'm going to show you that. Let's disable the roads. So this is Kisi here. Now, this is Kisi at this date down here that says 11th of, I assume it's 11th of May because this is in ISO, it's an ISO date of this year. So this image is from May this year. Now we can see older images if we go to this little clock up in this menu. So if we click on that clock, we get a time series here, and we can move over that time series. So let's move back to 2019, and there are several images for this town. We can move down here 2010, 2004, and the oldest one that we have is, we can scroll, is 1985. You can see that the resolution of this image is much lower. So usually resolutions are much better if they are more current images. Older ones have less resolution. But still, we can see the changes over time. Check 1985. Check how the town changed to 2005. Well, this one is not a very good one. We have some clouds. Check 2020. So you can see that the town has changed quite a bit. The whole area has changed quite a bit. So again, let's go 2009 to 2020. So this is super important because when we delimit locations, we have to keep in mind that they change. They change in shape and they change in size. And sometimes they change in position. For instance, for rivers, it is very common that over time the rivers change the places where they go through. And so exploring this might help us delimit the locations that we need to georeference. As we have mentioned before, when we georeference, keeping the date in mind is super important. And ideally, we should be georeferencing with maps that correspond to the date where those locations were recorded, which is often not possible. But then it will become super important to report which imagery we're using. So when we record the sources that we use for georeferencing, we say, well, we use Google Earth. We did the georeference at this date. However, if we're using an image that is from a different date, for example, 2020, we should be saying that we're using that image as a source from 2020. Because as you can see, the result can be pretty different. Okay, so that is about historical images. If we close this little clock, we will go back to the imagery from the closest to today, which is from May in this case. Okay, now I'm going to show you how to create points and save points on Google Earth. So suppose that we want to create a marker, put a marker or on some place here. So I want to put a marker in this property. So what I'm going to do is go to this little yellow pin up here, click on it to add a place mark. When I click on it, this window opens, and this window allows me to name that place mark, and I'm going to put it, I'm going to be very not very imaginative. I'm going to put it place mark 1. This is a terrible name. Do not do this. Just be more specific when you do it. But I'm going to name it like that. And so this place mark, where it's standing now, it has its latitude and its longitude. So we have the coordinates for that point. And while we have this window open, we can move this place mark to where we want it to be. So I'm going to move it. I like this property down here because I want to show you then how to center it. So here, you see that the coordinates change as I move it in the window. The coordinates change. Okay, I'm going to place it there. When I place it there, I can, once I have it on the spot, I can change several things for this place mark. So for example, the style and color, I can say, well, put the label is the name of the place mark in yellow. Check how it changes. You see how it changed to yellow. And I want the icon to be red. And so the icon changes to red, etc. So we can play with that a little bit. If I click OK here, it's going to save that place mark to the temporary places. That means for our working space right now. So here I have a place mark. I should have put it here, but I had it click on the other one. So here's my place mark that I just created. If now I realize, oh, I'm mistaken, it should have been here, and I want to edit the position of this place mark. If I try to do something on the pin, I cannot. So I have to go back into the properties of the pin. So I go here to the place mark, right click, There I select properties, and that window opens again. And again, while that window is open, I can move the place mark to where I want it to be. And then I say, okay, and now the place mark is moved to where I wanted it. If I want to save that place mark so that I can use it later, the best thing to do is either to move it to some folder within my places here, because those stay with Google Earth. So the next time I open Google Earth, those will be there. Or if I don't want this to have many, many points and polygons and stuff, which makes Google Earth a little slower, what I can do is save it to my computer and then open it whenever I need it. So to do that, I right click on it and I put Save Place As. And in there, I choose, well, let's put it in my folder, module 4, place mark 1, and I save it. Okay, so now I can erase it from here, or if I close the program and this was in temporary places, this will disappear on its own. Careful with that, because if you put many things in temporary and you don't save them, you will lose them. So now I'm going to delete this point, and I'm going to show you how to open it because I saved it. So I will go to File, Open, and in module, in my folder, I have to navigate to my folder. I have here my place mark 1 that I just created. I put Open, and there is my place mark. Again, it opens in temporary places. So if you want it permanently on your Google Earth screen, you should move it to some other folder here just by dragging it. I can drag it like that into this folder, for example, where I already have other things. In here, you can choose to show it or not show it. Show it, not show it. Just by clicking on it, you can make it disappear, but still have it at hand. So that's for markers. So now one interesting feature for these markers is that here we have it kind of at the bottom of the map, of the right down corner, but I can move the map and I can put it in the center more or less, but I'm not sure it's the real center. So what I can do is right click, properties, and in here in view, I can reset it. And if I do reset, what it's going to do is place this marker in the middle of the screen, in the middle of the screen. So I do reset. Here it has a trick because it puts some tilt, it inclines it, and I'm going to keep that tilt to 0. Enter there. So now I have the place mark in the exact middle of my screen, of what I'm seeing on my screen. So that's a way to center the point. This is going to be useful. I'll show you when we see polygons. Okay, so that for place marks. Now I'm going to show you how to make polygons in Google Earth. So to make polygons, let's take one of these fields here, just to make it easy. Okay, let's zoom in, and we're going to make a polygon that contains this field here. It's a very small polygon. So what we're going to do is go to the tools in this menu up here and choose Add Polygon. We can also do it from here, from the Add menu. Add Polygon is the same, or from there. So again, a window appears where we can name the polygon, and we're going to put it, we're going to name it again, very badly done, polygon 1, and we're going to draw it. So I'm going to start clicking on the screen to draw the points of this polygon. Okay, so my polygon is pretty simple, very, very simple. And I can adjust every point of this polygon just by clicking on it and dragging. So suppose that I need to adjust it. Well, I can do that. One thing that Google Earth has different from Google Maps is that depending on your active point, which is the one that you have clicked, you see it here in blue or green, as opposed to the red ones here. This is the active point, the one is in blue. And so if I add a new point, check what happens. It's going to add it after the active point. So if I wanted to add a point down here, I have to first make this the active point, because the next one is going to be that one. And so I can keep adding points. Suppose that I want to enlarge this to include all those two fields, and we can drag the points wherever we need them to be. To erase them, we just click delete on that point and it deletes it. So we make it the active one and delete. Here now is the active one. I'm going to add them again. So that's how we draw polygons. For these polygons, we can also change their style and color. And so, for example, for the area of the polygon, we can have it just be a line or just be the internal part of it, be a field polygon, or both field and outline. And we can change its color. So let's put it yellow, is easier to see, I think. So that could be one option. I like using them just outline because it's you can change the color of the line as well, and its thickness. We can put thickness 3 and its opacity, etc. So that helps us visualize it on the map. Okay, so if I click OK, that polygon is going to be kept as polygon 1. In this case, since I was already in a folder, it's already in this folder here, but we can move it around. And otherwise, it's going to go into temporary places. If you have everything empty here, it's going to go by default to temporary places. So that's our polygon. So again, if we need to modify it, we cannot do anything on top of it as is. We have to go right-click, properties, and then we can edit every single point and edit the name and the style, etc. Okay. Again, if we want to save it, we can do right-click, save place as, and we choose here the destination on our computer. I will call it polygon 1, and I can erase it from here. Delete. Are you sure you want to delete? Yes. And since I saved it on my computer, I can go here, File, Open, and here is my polygon 1. I can open it and it will show it there. You see that when it opens from my computer, it puts it automatically in temporary places. Again, if I want to keep it for the next time I open Google Earth, that is already there, I can move it to any of my folders within my places. Okay, so that's how we draw a polygon, how we modify a polygon. And as we did with the place mark, we can also center it. So to center it, we're going to go to Properties, right-click, Properties. We're going to go to View. We're going to Reset. And again, we have to modify the tilt. We'll keep it to 0. Enter there. So that polygon is centered on my screen. So what's the beauty of this? Well, the beauty of this, let me go zoom in and undo this. Let's see, I will have to recenter it. Maybe it's a little small to show this one, but yeah. Let me go to another polygon. I'll go to a polygon that I have already made for a piece of Mount Kenya. So this is Mount Kenya. I drew a polygon around it. I will take the borders layer out so that it doesn't interfere. And so I can center that polygon, Mount Kenya again, Properties, View. I will reset it and reset it with a 0 tilt. Okay, that's center on my screen. And so once it is centered, once my feature is centered, if I put a marker here, a place mark, this little yellow pin is going to put it exactly in the middle of that polygon, in the geographic center of the polygon. Why? Because this is centered in latitude and longitude, and by default the pins appear also in the middle of the screen. So if the polygon is centered and I add a pin, I'm adding it at its geographic center. So I will call this place mark Mount Kenya geographic center. And I can get the coordinates for that point, which are provided here. So this would be the geographic center of the polygon that I have drawn here. Okay. I will save it, and here I have it. The Mount Kenya, I can turn it on and off, the geographic center for Mount Kenya, for the polygon that I provided, right? Okay. So now we're going to see tools. We're going to come back to Mount Kenya, but we're going to see some tools for measuring in Google Earth. So let's move to some place that has a road somewhere. Let's put borders and labels so that it's easier for now. Okay. I'm going to zoom here into Naivasha. Okay. And I'm going to show you how to measure with Google Earth. So Google Earth up here has a ruler, and with that ruler, we are able to measure different kinds of things. So one thing is a line, just a straight line. One important thing, if you have this mouse navigation enabled, it allows you to move the map around while you're measuring. Otherwise, you won't be able to move up and down the map. So this, you might need to click and enable that. So if we're measuring a line, it's a straight line. So check, I'm going to put a point here and a point there. Or maybe I can do it down here so that you can see it better. I can measure that distance, for example. It's a straight distance. So I can grab it and move it, but it's always straight, this line. And in here is going to give us the length of that line. And you can change the units to whichever unit you need. I have it by default in meters. Now, an interesting, very interesting feature that this has is that it gives us the heading. And so remember that for a good locality description, one of the best ways to do it is to provide orthogonal directions. But there is also a very good way to describe, that is saying in which direction we're moving and how many degrees exactly. So for example, if we're trying to point to this place here, we can say it is this amount of degrees to the east, right? So from the vertical, it is the amount of degrees that is shown here. So if I'm moving this way, it's 37.09 degrees from the vertical, that is from the north. So we can use that heading for describing. So this is a very useful tool. Also, in relation to one question that was asked before, here we have the length on the map and the ground length. In here, this is pretty plain, the surface, so it won't have much difference. But if we're measuring on a mountain, the ground length and the map length will be different. So we have the length on a plane or the length following the terrain. So that will give us those values here. So this is for a straight line. Now, suppose that we want to measure a path. So it's a route that is not straight. Like, for example, here, this curve that's here. So what we're going to use is the path tool. And so we can start there and move here and start putting little points all around the path that we want to measure. And we can modify each point to adjust it. Again, be careful with which is the active point if you want to add more, because there you see that it added after the active one. And here we will have the total length of that path. We could click on this option that is show elevation profile. And so what it will do is show us, sorry, that point is show us at each point. You see how I'm moving the graph below and it moves the arrow on top of my path. So at each given point is giving us the elevation and also the distance. So you can see at the very bottom here that we're moving on distance from 0 to the whole length of our path. That is 2.17 kilometers. And we have the elevation profile at each point. So this might be a useful tool as well. So we can also use a polygon. And so we can draw a polygon here and measure the perimeter and the area. Again, we can change the units of that polygon. We can make it as complex as we want. And for all of this, the lines, the paths and the polygons and the circles that we're going to see in a moment, we can save those. And so if I want to save, for example, this path that I have here, I can click save. And it's going to be path, I'm going to name it path 1. I'm going to mark it with yellow. And I'm going to make it much thicker. And so I can save it. And now I have it here, my path on my temporary places. And again, I can save the place to my computer, call it path 1. And then I will erase it from here and I can open it back again. So here I have my path. So you can see that anything that you measure on Google Earth you can save it. So this is really, really a good thing because it saves us a lot of time when georeferencing. You can save just whatever, lines, polygons, whatever you want. Now I'm going to show you how to make another type of measurement here in the ruler, that is a circle. So suppose that we wanted to measure, let me put this down here. Suppose that let's make a polygon first. I'll make this polygon, very, very simple polygon. So now I want to make a circle around it and want to measure that circle. So what I'm going to do is put circle, click on there, and oops, and extend that circle, clicking by keeping the mouse click. I will extend it outwards, and I can put it back. And if I click on this point here at the end of the radial, where the radial touches the circle, I can make it bigger or smaller. If I touch in the middle, I can move it around. And so I can make it smaller to fit this a little more, and then I will move its center. Okay, so more or less, I think I have the minimum circle that can encompass this feature. So here, what we can see is the radius. We already have the radius of this circle. We have the area, and we have the circumference, right? The perimeter. So this is very useful because we can get the radius from here. Now, let me go back to Mount Kenya because I want to show you something. Again, double click here and go to my Mount Kenya polygon. Okay, that is centered. Remember that is centered on because I just double clicked it, so it puts it in the middle of my screen. And here I have the pin that we assigned as a geographic center. I could draw a circle here and save it as well. I have already done that. And I have it here, a circle that goes around that Mount Kenya. Now, check this out. I can go to properties. Here I can edit every single point of that circle if I want it. I will keep it as a circle, but if you want it, you can change this outward, inward, and so I'm going to cancel that. But I'm going to center this circle. So I'm going to go to View, Reset. I'm going to put the tilt to 0. Okay, so now what is centered is the circle. Is the circle that goes around this polygon. And I'm going to put a new place mark. That new place mark, let me put another color to it so that you can see it better. And the label, we're putting it in orange. Okay. This new place mark is the center of the circle. It's not the geographic center of the polygon. It's the center of the circle. And since the circle is the minimum circle that encompasses the polygon, this center is the corrected center. So we're putting Mount Kenya. Here you can see how they vary. They are not the same. Mount Kenya, corrected center. So they are close because the shape is pretty much is closer to a circle. It's more than round. Oops. But you can see that they actually fall on different places. This is the center that we determine as the geographic center based on the polygon, and this is the center that we determine the corrected center from the circle that we just draw around that polygon. So here is a little moved, sorry for that. But so that you can see how to determine centers and corrected centers here on Google Earth. So I'm going to show a couple more functions for Google Earth that you might find useful. The first one is, suppose that we have a spreadsheet with a series of coordinates for points where we went collect some specimen. So suppose that we have, for example, something like this. I have a series of points here from different collection sites, 1, 2, 3, 4, and each of those points has a latitude and a longitude. So I want to plot those points in Google Earth. What I will do is save this information, save this table as a text file, as a CSV, comma separated values. So I'm going to do that. Here I'm working on Excel, but you may work on any spreadsheet. I'm going to put save as. I'm going to choose where, and here, when we determine the type of file, I'm going to choose CSV. This comma delimited. Sorry, this is in Spanish by default, but it's CSV. I have already done that, so I'm going to save that. Okay, so now I have this saved as a CSV file. In Google Earth, I can go to File, Import, and I can bring back that series of points that I just saved as a text file. So I'm going to open that file. Oops. Oh, it doesn't want to do that. What am I doing? Okay, I'm going to open that file. And here is going to ask me which kind of format that file has. For me, the separator is semicolon. So you can see here a preview of the table that I just showed you. So it's reading it correctly. I'm going to go to next. Here it asks, well, which is the latitude field? Which is the longitude field? In my original table, they were named that way. So it recognizes automatically. And then it gives us which kind of field each one is. So this is correct, it's interpreted correctly. So I'm not going to go into the details of that. I just want to show you. We click finish. I'm not going to apply any particular style template. We could, but what it's going to do is open those points on the map. So here you can see test CSV. We have to click it to be able to see them. And there are our points. Let me put it down like that. And zoom it out a little bit so that you can see them. Okay, so these are my 4 points plotted on the map. I can come here to this CSV, right click, properties, and change their color, change their name, center on them. So for instance, I'm going to put the color yellow for the icons. You see how it has changed. Okay. And so each one, if I click on it, I will get the information that was associated to each point in my original spreadsheet. So depending on what I have on my spreadsheet is what I'm going to see here. So that's one function that we can use. If you have several locations that you want to plot, that's one thing that may be useful. The next thing I want to show you is how to upload other types of information. In this case, I'm going to add to my map a layer for forest reserves. So what I did was I went up to here. Let me see where it is. I went up to here to the Global Forest Watch, and I downloaded a file containing a series of forest reserves in Cameroon. And so I'm going to show you this. You see this in blue are the forest reserves polygons that I want to bring to Google Earth. So I downloaded this file from this web page, and I'm going to upload it to Google Earth. So I'm going to go to File, Import, and here I have the file that I have downloaded from the web page. There is the forest reserves. I'm going to open that file, and what I get is this series of polygons that are included in that KML file already plotted on the map. Let's put it, let's tell there, center there, north up. I'm going to put the borders for reference there. Okay, so I can see all these forest reserved polygons that I downloaded from anywhere, from a given web page. So if you have polygons for national parks, for reserves, for, well, it could be for just anything that you can get from some other sources, from governmental sources or whatever, you can always upload them to Google Earth as KMLs. They accept a bunch of different kinds of files, GeoJSONs, and a lot of other formats. So in here, each of these ones, depending on the information that comes from the source, in this case, Forest Watch, I can click on each of these, and it gives me a series of characteristics that includes, well, the kind of forest that it is, the name. It has here the extent, the number of hectares it has, the surface of this reserve, and that for each one. Of course, the kind of information that you will find here will depend on what the source is providing. If I download it from a website that doesn't have all this information, well, I might only have the polygons. But otherwise, we can have a lot of information included here. And so this can help us when we're delimiting locations. Depending on the layer we're using or the information we're using, it can help us find locations on the map using other resources. And the last thing that I want to show you about Google Earth is the superposition, over the imposition. How do you say that in English?
Superposition.
The overlapping, superposition,
Overlap.
the overlapping of images, just plain images on the map. So for that, I'm going to use an image that I took from a web page that is called, I'll show you here, the David Ramsey Map Collection. This is a very interesting resource that has very old maps available as images. And so what I did was I looked for some maps and I found this map here that is from, that is deploying the coast of Accra in Ghana. So let me see if I can show you how the map actually looks as an image. Is a JPEG as a format, JPG. So this is the map that we have. It's an old map. You can see that it has very little things, but I'm going to show you here. For example, here it has a reference that says the castle, barracks, and here see the shape more or less because we're going to see it now in Google Earth. So what we want to do with this is overimpose this image to the map to, for example, find where an old location is nowadays, currently. So in Google Earth, I'm going to move to Accra right now. Let's zoom into Accra and let's try to recognize that shape that we just saw on the, let's see, where is it? I believe it's here. Is it here? No. Is it down here? Wait, I'm missing the, I'm losing the zoom is confusing me. 1 second.
Southwest. There you go.
That would be east anyway. Okay, thanks. So the part that we will be looking at is around here, and you will see it in a moment. What I'm going to do is add this image, this JPEG, this is a photo, to the map. And so I'm going to go to add image overlay. With image overlay, here I'm going to browse. I'm going to look for it in my computer. I have it here, and I'm going to open it. And it's loading. Okay, so now the image is loaded. So what we need to do is place it correctly on top of the map. If I use the central cross here, I can move it around, up and down. With this little diamond here, I can turn it so to better orient it, and I can enlarge it or make it smaller, either in both directions or in one direction. Now, to be able to put it on top of the map, one very useful thing is this bar here that shows us the transparency. And so we can diminish here, we can make it more transparent, and so we see the map underneath. And you have to believe me this because I've seen it before, but this that was referred to as the castle in the old map is this point here. So I will try to make it coincide there. And let's look at the image again. Here is the river coming out. And so the river coming out in here is much more to this side, is here. So we need to enlarge this image to try to make it fit. You see how it starts to fit slowly. We have to move it up. Well, we will need to accommodate this quite a bit and rotate it and make it larger, but we can, the idea is that we can overimpose this on top of our map. And this is very useful because we can check for all locations on this image and see what they are called now, because sometimes we can find this map, but we are not really sure where it actually is today. And so by doing this, we can find some historical locations faster. You have to be very careful, however, because as we saw in the first classes, the projection of the maps are very important. So Google Earth is using Web Mercator as the projection, but some of the images that you might overimpose might not be using that projection, might have just any other. So be careful when you stretch images and make sure that things coincide not only on one side, but also in the other. So for example, try to make this coast coincide, but try to identify some of these roads so that you make it fit as well, to make sure that you're looking actually at the right places. Okay, so this is all that I wanted to show you about Google Earth. I'm going to cancel this. So I just we're a little behind here. So I suggest that I show you GeoPick, and then we come back to Google Earth with the questions. Is that okay?
I think you need to do that because we must show GeoPick.
Okay. Okay. I'm going to move to the next tool then, which is GeoPick. So GeoPick is a tool that is meant to help us georeference, and in particular georeference when we have features only types of localities. So that's what it's best at. So let's move here back to Africa. GeoPick looks like this. I believe John has already sent you the link on the chat. Otherwise, it's in the materials that we've shared with you. In here, we have a couple of functions that I want to show you. First, we have, well, a map that we can zoom in and zoom out. We have different layers. We can see this map as OpenStreetMaps, as the Google default, as the Google Terrain, Google Satellite, Google Hybrid. These are all kinds of views that, sorry, that we have already seen for the other tools. So this is not new. Then we have a couple of parts of this tool. Up here we have a location search bar. On the left we have the layers, the zoom, and a series of tools that will appear. We'll see that in a minute. Let's see, I'm gonna clear it up here. We have to draw lines, to draw polygons, and to draw circles, and also to put well-known text, WKT, that is already made polygons, the values for polygons, and we can edit points. So those are the working menus. And here on the right, if we click on this plus, we have the menu that I'm most interested in, which is the actual georeference of the places that we will be looking for. So this tool will give us latitude, longitude, coordinate uncertainty meters, the datum, the spatial fit if it's appropriate, the precision, the protocol, the georeference sources, and we can add georeference by remarks, and we can then export that, copy that to the clipboard so that we can move that information to our georeference table. So it gives us the georeferences, which is awesome. So we're going to start by looking here for a location. For instance, we can look for, let's see if it finds it, Kadoma in Zimbabwe. Sometimes it takes a little while because it's looking for it in OpenStreetMaps. And so it might be a little slow. Kadoma is in here. Let's see if it finds it. I think it's getting a little slow. Otherwise, let's look for let's look for an area. Charara, and see if it finds it. Safari area. The slowness of this is coming from OpenStreetMaps, not from this tool. So we have to be a little patient for that. Just give it a second. I don't know why it's taking so long. See if it finds it. Okay, come on. There we go. So it's not finding the Safari area, but it's finding here in OpenStreetMap the city. So let's go just for the sake of the example to the city. So it finds the place there. So in this case, it only finds a spot and it's not finding any polygon associated. But let's see if I can find one for you that has a polygon associated. Let's see. I'm not sure if Kizzy is, so that we keep the same examples. This is Kizzy County, so this is Kizzy, the city of Kizzy. There. Okay, so it has found a polygon for Kizzy. You see that the polygon is pretty different from what we were seeing in Google Maps. So this polygon is coming from Google's from OpenStreetMap. So again, be very careful with which polygon you trust. Let's go to the satellite view. So you see that it's including much more than the other polygon. I'm not saying one is right and one is wrong. I'm just saying they are different and we have to be careful. So once we have found this location, we can import that location. And by importing that location, just clicking there, this web page will make the circle around it, the minimum circle, and will give us the corrected center. And so if we go here, what we will have is the latitude and longitude, the coordinate uncertainty in meters that is calculated following best practices, the datum, point radius spatial feed, the precision, and everything we need to report the georeference. So basically, if our location said Kisii, Kenya, or Kisii town, or Kisii town, Kenya, and we're referring to this town, we look for it here, and we already have the georeference. So I know you might be thinking, and why did you explain all that you explained before if it was so easy? Well, because we need to know the basics of the processes to understand how well this is actually representing the location. But so basically for features for which we can find the polygons in OpenStreetMap, which is not always the case, we just import location and we get the georeference automatically. So what we can do with this is copy. I have to put my name here, right? Because I have to add georeference by. I don't have any remark for this one. And I can copy to the clipboard. I'm going to copy it with headers, which means with the names of the columns. I can also copy it just the values, but I'm copying it with headers. And so I'm going to go to a spreadsheet here, and I'm going to paste it. Where is it? There. So what it's doing is pasting every field for the georeference so that you can see it. So it's pasting the latitude, the longitude, the datum, the uncertainty in meters, the precision, the point radius, even the footprint, because it's a polygon. So this is a footprint, this is a polygon. You can see all the coordinates that make up that polygon. The georeference by, the georeference date, the georeference remarks, if I put any, etc. So everything for the georeference is here. So we can basically copy paste. Now, suppose that we don't have a polygon. Suppose that OpenStreetMap does not find a polygon, or that we need to draw a specific thing that the location describes, that is not a town, it's not a mountain, it's a polygon, X polygon that we need to make. So I'm going to clear all here from the little trash bin, and I'm going to draw a random polygon. Suppose that I want to georeference this part, because the description says the location is this one. So I'm going to use the polygon here, draw a polygon, and I'm going to start drawing a polygon. Okay, I'm going to draw like that. So this is my location. Again, one can edit these points by, well, first I have to close it. I haven't closed it. I have to click on this last one, and that draws my polygon. If I want to edit it, because I did some point wrong, I put some point wrong, I can go to edit layers, and then I can move every point, any point to wherever I need it to be. I can save it. And once I draw the polygon, what the tool does is automatically create the circle with the center, which is the corrected center for the circle. So I go here, and what I get is the georeference for the polygon. So again, I have the latitude, longitude, the coordinate uncertainty meters, the datum, everything already ready to copy paste into my spreadsheet. So the georeference is ready, basically. So this is a very, very powerful tool. Again, this works for locations where we have features only, right? That we can draw a polygon and draw a circle around. Still, it can give us the radiuses for other types of locations. So sometimes it is useful, for example, if we have distances from a place and we need to know the extent of that place, the radius of that place, we can still use that radial that is provided here to keep on going with the calculations using the georeferencing calculator. So I'm going to clear all here. We can also draw circles if we need to. And when we draw circles, we can have the center there. And so again, we will have the center and the uncertainty associated with that. And we can edit them as well. And we can draw paths. Suppose that our location says, oh, wait a second, because I'm gonna move out a little bit. Suppose that our location says this piece of the path, road between this intersection and this intersection. Okay, I can come here and draw a path right there. I'm doing it a little off the road. Sorry for that. I'm gonna edit it in a second. Let's edit this, and it's between there and there. Okay, here we go. So more or less like that. I'm gonna save that. Okay, save. So with that road, it also calculates the georeference for that. So you can see that it's giving us the center, the corrected center, and the radial. It's calculating besides the whole coordinate uncertainty that is associated with that path. So we can georeference features, either features that have a particular shape or also linear features, because paths are no other than linear features. So those are the basics of GeoPick. We also have an option to provide a polygon. If we already have a polygon, we can paste it here and have GeoPick georeference it. So for example, suppose that you had the location was a reserve, a forest reserve, and you can get the polygon for that forest reserve from some web page or some governmental service. So you get the polygon. So you can paste the polygon here as WKT. And once you paste it here, GeoPick will plot that polygon and provide you the georeference for that. So that's also useful. So sometimes the polygons do not come as WKT, but there are some online tools that you can use to convert polygons to WKT. And so you can upload them here and have the georeference immediately. So that's another thing. And the last one is that you can paste coordinates and coordinates uncertainty in meters and modify them if needed, and obtain a new coordinate uncertainty in meters. So this is just pasting latitude and longitude, and coordinate is going to plot it on the map, and you can correct the uncertainty. So that's basically all the functions that we wanted to show you from GeoPick, which are awesome, really. It saves a lot of time. So now, sorry it took us a little longer than expected, but now we're open to any questions about Google Earth or GeoPick or whatever you need.
One quick mention here from what you were showing with GeoPick. Remember that in Google Earth, you're able to save polygons into Google Earth and also to your desktop. With GeoPick, GeoPick doesn't save anything in the application itself, but it does allow you to save, as Paula showed you, off to spreadsheets. With that, it also saves the polygons in the footprint WKT field. And that means that you could save a place that you're going to use over and over again, and then paste it back into GeoPick when you need it using that WKT function that Paula just showed you.
Is there anything on the chat?
We don't have any open questions at this time.
Okay.
Now we do.
Okay.
So Benford asks, are there any differences between Google Earth desktop application and the one on the web?
I believe there are some functions that are not available on the web version, but I couldn't tell you exactly which right now because I tend not to use the web application, and so I'm not sure if of the new things that they have incorporated. So I can check and let you know the next time. I can tell you exactly which the differences are. I prefer the desktop because I can save stuff locally and it doesn't need the connection, and well, and I'm used to it as well. But I can check for next time exactly which are the things that are not available in the web one. Connection is one of the differences.
Okay, Beston has a question that I'll answer if you don't mind, and that is there any need to use the georeferencing calculator if you know GeoPick? The answer to that is yes, because GeoPick is able to georeference geographic features only, but it's unable to do any offsets or any of the other locality types. So you need the georeferencing calculator for all those other types of locations.
Okay, I saw a hand up. Tatian, was yours hand up? Well, there is
Hello,
another question. Yeah, go ahead.
Yes, this is Tazia speaking. So my question is, I didn't understood where the importance of overlaying the maps in Google Earth, so because maybe it doesn't consider the coordinate referencing system. So could you please tell us more about it? Thanks so much.
Yes, can you repeat your question because I'm not sure I understood it.
I was asking about the importance of overlaying maps in Google Earth. So because I found that it doesn't consider the coordinate referencing system. So that's my question.
Let's see. We're talking about Google Earth and putting maps on top of it.
Yes.
Okay, so I understand that you're referring to the last thing that I showed here. Is that right? Imposing images.
There are actually two considerations, I think. One is the last one where you have the image that isn't in a coordinate reference system at all. And the other is where you have the map layers, such as those forests that you showed for Cameroon, which in the original might have a different projection or coordinate system.
Well, yeah, one should check in the source. In this case, for the reserves, it was the Forest Watch. The Forest Watch is probably using what's that? A projection that is
WGS 84.
compatible. Yeah, it's probably using a projection that is compatible with Google Earth and Google Maps, because is what most people use. However, we can always check at the source if that is really the projection they are using, if they are using the Mercator, the Transforms Mercator, which is the datum they are using. But what you will need is first to download this data from another website. If you haven't downloaded it, it's impossible to load. You have to have it on your computer. And once you have it on your computer, you have to go to what we said before, import those data onto Google Earth. Here you can see, this is something I mentioned before, but among the files, the file formats that Google Earth allows, there are like a lot of different formats of files that you can put on. You can put CSVs, you can put shapes, you can put GeoJSONs, you can put geospatial, different kinds of geospatial files. And so it accepts a lot of different formats. In this case, what I was using was, one was a CSV for the point. Another one was a KML. Because I downloaded the forest as KMLs, as polygons, you can also download it, I believe, as an SRAY shape from Forest Watch. I believe they have that format available, but that depends on the source, which formats the sources have available. If the files are using a projection compatible with Google Earth, you shouldn't have any problem whatsoever. If they don't, well, you have to make sure how you adjust those files to this map so that we don't get distortions. For the polygons, if we zoom into any of these polygons, once you upload them to Google Earth, suppose this one that is the Belabo Forest or Forest Reserve, if I go here, I can check each of the individual polygons, and I can edit them probably. So I'm going to go to this one because here they have no names because of how they were created. So let's just look at that one. So this is one of the forests in that file, which is this one. And so let's see if it's allowed to, with properties, as we did with any other polygon, you could edit them and adjust them. So you could also use a base file from some source and say, well, no, you know what? This organization that made this polygon just forgot that this little piece down up here is also included in the reserve. And so you could edit them as well, just as any polygon, if you're working with this kind of files. So that's another option. When you're working with images, however, that is way more difficult. I mean, you have to stretch them and reorient them, turning them. And usually old maps have very different projections, and sometimes things are pretty distorted. Like you look at an old map and you say, well, but there was a peninsula here, and on the map it's just a little thing. But that's what we have to deal with. And there's no way around that other than being careful about interpretation and try to be conservative. I hope that answers what you were asking.
I'd like to make a clarification about a couple of things. So one was about the projections. So that JPEG image was an image on a flat map, a piece of paper. That was a projected image. It was in some projection, maybe not even one that's defined because it was just a drawing. But these forest shapes quite likely are unprojected. That is to say that they are coordinates in the WGS coordinate system, and no projection is involved at all. That would mean it would be plottable directly into Google Earth without any adjustments. If the original shapes and so on were projected, that original data would have to be reprojected, or rather unprojected, into the WGS 84 coordinate reference system in order to be imported into Google Earth and to plot correctly. I hope that helps.
Yes, these different sources have different files that you can download. I'll show you here, because I kept it open just for that purpose. Let me see. Here you can see the details of the file that I downloaded, what are the attributes, etc. And you can see the source data and the metadata. This is for this page in particular. And so when you put download, you can download a CSV, a KML, a shapefile, a GeoJSON. So this source provides all these different formats that you can download. Some other sources may not. And some sources may allow you to just download things that are already projected. And so in that case, instead of opening them on Google Earth, you should be dealing with them in some GIS software. So you can open that in QGIS or in ArcGIS or whichever GIS software you use. Deal with the projections there is much easier, and export a KML from GIS. You can open your file there, export it as a KML, and open it as a KML in Google Earth if you want it. That would be the easiest route if we have issues with projections. Giles, you say the maps do not load. It might be slow. I had some problems just before with loading the locations, and we believe it's a problem from OpenStreetMap, the communication between OpenStreetMap and GeoPick. But let us know if it still doesn't work for you, so that we can check with the developers. Okay. Are there more questions? Are there any hands up? I don't see any hands up. But...
Can I make a comment quickly?
Sure.
Giles, if you could tell us what browser you're using and etc., it would be good to know. Right now, GeoPick is loading here locally, but we have a very, very good connection, so it doesn't take any time to load. Okay, I'll try Safari and tell you. I can try that quickly, actually, and tell you if it's working there. If not, please try Chrome or Brave or Edge, Microsoft Edge, any of those things. But I'll try Safari right now and see if I can get it to work.
So for everyone, I suggest that you get into each of these tools, particularly Google Earth and GeoPick, and play with them and try to draw polygons and save them and calculate your references and see if you understand what the output is. And well, play around because this is mostly practice. You have to get, if you're not yet familiar with the tool, you have to get used to it. And then you're going to love it because it's really fun to work with these tools. But try it and get back to us with questions, and we will have the questions and answers session on Friday. So we can play a little more there.
I can confirm that locally, I have the same behavior with Safari as Giles is reporting. So
Okay.
I will report that to the developers. But in the meanwhile, if you could try one of those other browsers, we know it works in Chrome. We know it works in Brave. We know it works in Edge.
Are there any other questions that you want to ask today?
I think it's no point.
I hear someone talking, but I don't know who it is. Okay. Okay, for all of you for whom GeoPick is giving you trouble, just we suggest that you reload, you try the other the other browsers, and you can send us an email if you keep having those problems. Someone is asking if we can have a WhatsApp group for fast communication. Well, I already have like 10,000 WhatsApp groups, but if you prefer that, I don't know if you were referring to all of us, including the trainers or not, but if you really want to have such a group and you want us, the trainers, in it, let us know. It is possible from our side. But let's set it on email. Let's arrange that on email. If someone else wants to do that, just let us know and we can share our phone numbers. Okay, I don't see any more questions, so we're already almost half hour after our ending time. So I invite you to try the tools and to gather questions. Send us questions or leave them for the question and answers session, whichever you prefer. I'm going to stop sharing my screen and I'm going to pause to stop